Hey, and welcome, gurus, to this lesson, Application Gateway Concepts. I'm Chase, your Azure Training Architect here at A Cloud Guru, a Pluralsight company, and it's in this lesson that we're going to start off by describing what Application Gateway is. Then we're going to talk about the thought process that's involved in picking a load balancing solution so that we can understand why we might choose Application Gateway. Then, to better understand Application Gateway, we'll compare it to Azure Load Balancer, a service we're already familiar with from the previous section, so that we can understand the difference between these two services and the features that they provide, and why we might choose one over the other. We'll then take a look at a high-level architecture of Application Gateway. We'll then review the SKUs that are available with Application Gateway and the different features that they provide, and then we'll bring it to the end for some key takeaways for this lesson. So without further ado, let's get started. Azure Application Gateway is a networking service that we use for load balancing between resources in a backend pool. Specifically, we're talking about compute resources here, like virtual machines or app services. And what we have here with Application Gateway is load balancing at layer 7. So instead of TCP and UDP at layer 4, like with Azure Load Balancer, we have HTTP and HTTPS. Layer 7 load balancing. And using Azure Application Gateway, we can balance for private and or public front ends, much like we can with Azure Load Balancer. And for Azure Application Gateway, what we're able to balance between as far as backend compute resources is a much larger list than that of Azure Load Balancer. We have VMs, VM scale sets, app services, IP addresses, or FQDNs, also known as fully qualified domain names. With Azure Application Gateway, we also have availability zone support. We can deploy into one or more availability zones in a region to provide us high availability across AZs. And also, with Application Gateway, we have multiple SKUs. Now, as you'll see in the demonstration, it really comes down to a choice between two different SKUs, a V1 and a V2, with optionally a web application firewall to protect those resources in our backend pool. We also get with Application Gateway the availability of using auto scaling to scale out or scale back in our resources based on demands of our traffic. We have path-based routing to be able to route to various resources inside of our backend pool based off of URL path or the URI of our resource, such as /pics or /images. And then we have multi-site support, where we can route traffic to multiple sites for that multi-site hosting behind our application gateways. And additionally, much like Azure Load Balancer, we have that health probe that allows us to check on the health of those resources in our backend pool to make sure that they are available to serve traffic. And if not, they'll be marked as unhealthy. Now, with Application Gateway, we also have support for TLS encryption so that we can provide encryption end-to-end for our Azure Application Gateway solution. So now that we know what Application Gateway is, working as a layer 7 load balancing solution for balancing between backend compute resources, it's time to talk about why we might pick a specific load balancing solution. When we're talking about load balancing solutions, we need to be thinking about at what layer are we trying to balance? Layer 4, layer 7, and when we're trying to balance inside of a public cloud like Azure, we need to think about, are we trying to balance for a region? Are we trying to balance globally across multiple regions? So for example, Azure Load Balancer is a layer 4 solution, and as we learned in a previous section, we can use it to balance traffic regionally, but we can also use it to balance traffic globally across multiple regions using a global Azure Load Balancer. Now, when it comes to thinking about Application Gateway, with Application Gateway, we would use it if we want to balance traffic at layer 7 regionally, because it is a regional resource that provides layer 7 load balancing. And these are the kind of things that we need to think about when we're picking a load balancing solution. So you can kind of use this Punnett square we have here for picking a load balancing solution for your reference as an engineer. Now, to compare Azure Application Gateway with Azure Load Balancer, I think what we'll find is that there are some similarities, but also some key differences that make us understand where these two services differ from one another. First, Azure Load Balancer provides private or public front ends, and Application Gateway provides private and or public front ends. With Azure Load Balancer, we're balancing layer 4 TCP UDP traffic. With Application Gateway, we have layer 7 HTTP, HTTPS, and HTTP2 traffic. With Azure Load Balancer, we have backend pools of VMs and VM scale sets. And with Application Gateway, we can have VMs, VM scale sets, app services, IPs, and fully qualified domain names. Now, architecturally, this comparison looks like this. We're familiar with Azure Load Balancer and its general setup and architecture. With Application Gateway, it is very close to the same, except for balancing at layer 7 to more backend compute type resources. So we have our Application Gateway, and let's say this is a public front end on this Application Gateway, so it has a public IP address, much like our Azure Load Balancer off to the left here. And behind this Application Gateway, we have some compute resources like VMs, app services, and on Application Gateway, we also have a health probe for these backend compute resources to check the health of them to make sure that they are able to serve our traffic. Now, traffic comes in from places like the internet via our Application Gateway's front end public IP, and then a routing decision is made to route the traffic to the correct target in the backend pool, be that a VM resource, an app service, an IP address, an FUDN, or a VM scale set. At a high level, the architecture of Application Gateway looks like this. In our region, we have a virtual network, and we have a subnet. And in our subnet, we're going to have our compute resources. And for our Application Gateway, we'll have a purpose-built subnet. We'll have an Application Gateway subnet, and it doesn't have to necessarily be named using any specific keyword like Azure Firewall. However, we do need to designate a subnet for this service. And the purpose-built Azure Application Gateway subnet is where we'll deploy that Azure Application Gateway resource. Now, we have to have a /26 CIDR at a minimum for this subnet. If we're using our V2 SKUs, we really want to use the /24 because that's what's recommended by Microsoft. However, it doesn't have to be a /24. We just need to make sure that we have enough private IP addresses available for scaling our Application Gateway solution within this subnet. So recommended a minimum of /26 and /24 for our V2 SKUs. Now, for our Application Gateway, we'll have that front-end IP configuration, be that public and or private. Then we have our listener component, and this is what's actually listening for traffic. And we're listening for traffic over things like a specific port for traffic coming in for HTTP or HTTPS, again, port 80 or 443. And then we also have a certificate configuration here that we use for that TLS encryption between the Azure Application Gateway and the client. And then we have a rule. And on this rule, we have the configuration details that tell where we're going to route this traffic. So this is really a routing rule. And on this routing rule, we have our HTTP settings that we use to determine how we're going to pass the traffic on to the client. So for example, HTTP or HTTPS, and we would use HTTPS in both the listener and the rule to provide that end-to-end TLS encryption. Now, on the rule, we also can create a custom health probe to establish checking on the health of those resources running inside of our backend. And once we have the listener, the routing rule, HTTP settings set up, we can choose our backend target, be that another listener or those resources inside of our backend pool, or redirection elsewhere entirely. And so what it looks like here is the client makes a request to the public IP of our Application Gateway. We have our listener. The listener matches, and optionally we can filter traffic using a web application firewall, depending on the SKU we select here. And then the traffic finds a matching routing rule and routes that traffic to one of the resources in the backend pool. So it finds the correct target and sends the traffic there. Now, Application Gateway SKUs provide different features. Again, it really comes down to standard V1 and standard V2, and then additionally, we can choose to have a web application firewall or not. The big differences between these two SKUs is that with standard V1, we have URL-based routing, we have multi-site hosting, so we can have multiple sites running in the backend pool and route traffic based off of those sites. We have traffic redirection, where we can route it to another listener or route it to a completely different site altogether using hostname. We have support for web application firewall on standard v1. We have support for TLS termination at the front end or end-to-end TLS encryption all the way from the front to the back. We have session affinity, much like with Azure Load Balancer. We have HTTP2 support. We have support for connection draining, which allows us to say we're going to have a connection draining timeout for resources when we deprovision those resources in our backend pool so that we're not disrupting our users and we move them over gracefully. We then have support for custom error pages and WebSocket support for standard v1. Now with standard v2, we get all of the v1 features, plus we get the introduction of auto-scaling, of instances. We also have zone redundancy support, and then we have support for static virtual IP for standard v2, and this provides us the availability to specify that private IP for our Azure Application Gateway. It also supports AKS Ingress Controller for Application Gateway. When we use standard v2, it supports integration with Azure Key Vault, supports rewriting of HTTP headers, be that HTTP or HTTPS. It supports custom web application rules and not just the managed rules that come with Web Application Firewall. We'll get into more on Web Application Firewall in a later section in this course, but just understand at this point that we have managed rules that come with Web Application Firewall that we can turn on or off. And then with standard v2 of Azure Application Gateway, we have the ability to create custom rules that we can turn on or off and use those together with the managed rules that come with WAF. All right, gurus, it's time to wrap up this lesson with some key takeaways. So the purpose of Application Gateway is really to understand that it is a region layer 7 load balancer that supports virtual machines scale sets, app services, IP addresses, and FQDNs in its backend pool. And it provides multi-site hosting functionality so that we can have multiple sites running behind a single IP address of our application gateway. Now, the components of Application Gateway are that front-end IP configuration, be that public, private, or both. Then the backend pool, where we have our backend targets, like our VMs and our VM scale sets. And then the listeners that are actually listening for traffic on specific ports, like 80 or 443. The routing rules we use to route traffic to the correct backend targets in our backend pool, or to other listeners, or redirect entirely to other host names elsewhere. And then we have the HTTP settings that we can use to control whether or not we want to allow TLS termination or end-to-end encryption of TLS for traffic going through our application gateway. And then that final component is that health probe that we use to determine the health of the resources running in our backend pool to make sure that those backend targets are available to serve traffic. All right, gurus, that wraps everything up for Application Gateway concepts. Thanks so much for joining me in this lesson, and I look forward to seeing you in the next lesson where we're going to get a little bit more in depth with Application Gateway.